This video covers the one sample t-test, what it is, when you would use it, and a work-through example in R. The one sample t-test is a way of statistically testing the difference between a sample mean and a known or hypothesized value of the mean in a population. So basically you have a value for a mean that you know, and you want to test whether the population that you're looking at, whether the mean of that population is different or not to that mean that you know about. Looking at the figure on the right hand side here, you have a population that you know the mean of, and this variable x that you've measured, you want to know whether the mean of this population is different or the same to the one that you already know. So for this, you need to follow the assumptions that I talked about generally in the t-test video. You must always check that the assumptions are met for your statistical tests. So when might you use this? What kind of scenario might you use this test in? So for example, some researchers wanted to look at blood cholesterol value in a group of patients, and they wanted to test whether this was different to what the recommended value is, what the kind of good level is, which is about 200 milligrams per deciliter of cholesterol, total cholesterol in the blood. So they know what the value is, that known or hypothesis value is 200, and they want to check whether that population is the same or different to that 200. If I just come out of PowerPoint and I go into R, I can show you how this would happen in R. First of all, I'm going to set my working directory. I set my working directory and I'm just going to feed in a file called cholesterol. Let's just have a quick look at what this is. This is the cholesterol level of 50 patients. What we want to do is compare the mean of this and see if it is different or not to that level of 200, which is deemed to be a good level of cholesterol in the blood. Let's just have a look at what those column headers are. The cholesterol level, so now we know what we need to put in when we're having a look. Remember, one of those assumptions is that the data is normally distributed. So to do that, I'm just going to use a histogram function. So you remember this from the data visualization workshop we did. I'm using hist, and then I've called the data set chol, short for cholesterol, and then I'm looking at that cholesterol level, and I'm using breaks equals 3. So I'm just going to have a run of this. You can see in the bottom hand plot here, it looks like it approximately follows kind of a normal distribution. You've got a nice kind of bell curve look to it. So to me that looks okay. We can proceed with a one sample t-test. So to do this, and as you go through and look at the other videos, you'll recognize that they tend to use the same sort of function, so this t.test. You're just then putting different things into the argument for what you want it to do. So for t.test, we use that, and then for a one sample t-test, we insert kind of the column of interest. So in this case, we're looking at that whole data set, and we're using that dollar function again to have a look at cholesterol level. So we want to look at the cholesterol level within this cholesterol data set. And we're using mu, which stands for the mean, and we're testing that against that mean of 200. So we want to know whether this cholesterol level, whether those values that the researchers have collected, whether it is different or the same to that 200, which is deemed to be the recommended or a good amount of cholesterol in your blood. So your null hypothesis would be there is no difference, and your alternative hypothesis would be that there is a difference. For the alternative here, you can specify it as two-sided, and so you're testing both the lower and upper tails, or you can do a one-sided test. And a one-sided test would be if you know that you're testing for either greater or less than. But in this case, we just want to know whether it's different to 200. We don't know, they might be lower, they might be higher. However, if we're testing patients where we know that the value could be higher, we might want to be stricter with our test and do a one-sided test or a one-tailed test, in which case rather than putting in two-sided here, we would then put in greater. So have a think about, Do you expect it to be greater or lower, or if not, stick to that two-sided or two-tailed test? So I'm going to run this line of code and have a look at what R gives me. R has given me the one sample t-test. The data that it's used is that cholesterol level in that cholesterol column, and it's now giving me that important information that I need to be able to report this test statistics. So we've got the t result here, and so it's a t statistic for the t-test. We've got the degrees of freedom, which you also need to report, and you have the p-value here as well. So it's given this to you in standard form. However, we never normally report this in standard form. So because this is 2.2 times 10 to the minus 16, this is a very small number. So we would instead report this as p is less than 0.001. Our alternative hypothesis that I talked about before is that the true mean is not equal to 200. And it actually gives us a sample estimate of the mean. So it's telling us that the mean of those patients is actually 225. So that's a lot higher than that 200. So in the case of these patients, compared to that known mean that we're looking at, it's a lot higher. So their cholesterol levels were a lot higher. And that is a one sample t-test in R.